got a 2018 Toyota Camry. It's got a 2.5 liter engine. This is actually the car I wound up doing a YouTube video on where I had extracted some data from the water pump because it's electronic, just to see what it's like, familiarize myself with it. That video ain't do as great as I thought it would, but I'll put the link in the description. But I did that because, well, even though the water pump has a common failure, well, what does it look like when we get the code that manifested? So anyway, it is what it is. I'm a little bit smarter with this car than what I was before I did the video. So I think maybe this is going to be the same thing. I'm just going to be a little bit more smarter than I was. So today, this car came in. It's in a limp home mode. It doesn't really want to go anywhere because of that thing right there. That mass airflow sensor has a circuit fault code, which is circuit faults are just going to be the easiest code, honestly, to diagnose in my personal opinion, which they are. I mean, you don't have to worry about any like a cam position sensor circuit fault. You don't have to worry about any sort of cam positioning code or its inability to function or delayed response. You're dealing with circuit integrity. So there's just no feedback. This is this equivalent. It doesn't work. That's the only code that's in the system. I'm going to show you the code through a generic portion and through the bidirectional portion, because there are two different codes, but they're going to point you to the same issue, circuit fault. This mass airflow sensor has a heating element in it. It's got like the hot film, like a tray inside of it. It also consists of not just the mass airflow, but it consists of the temperature sensor also. So you not only can have an issue with one side of the mass airflow sensor like we have now, but you can also have an issue with the heating element that measures the temperature of the air passing through. I think I spoke enough. We're at 2 minutes and 19 seconds. Let's go ahead and jump into what it sounds like, and then we'll look at the codes, and then we'll go into some testing, because the part unfortunately isn't local, and the lady, I'm pretty sure, doesn't want to go to the dealer because it's going to be expensive, but I will call tomorrow. The part O'Reilly has it. It's a blue streak, unfortunately. They're hit or miss. That should be here. So but hopefully this diagnosis is going to be precise to the point where I don't have to question anything, and it's just simply a mass airflow sensor. But with the circuit code, that's typically all it is, a sensor. This vehicle has 170,000 miles on it. We do have some impact type codes coming up. Let me close this door. These are the message center, reduce engine power, secondary collision, and yes, I have the hood up. Check engine light and the collision or some sort of secondary impact sensor. So that's what's coming up there. Let's see here. Now, I'm in the generic portion, and sometimes what will happen, if there's some history with other codes and it hasn't gone through its testing state, it's not going to ignore some of these permanent codes. So you can ignore most of the permanent here, and because I lightly triggered all these doing an initial assessment, just ignore those permanent, and I'll say it again, ignore the permanent ones. Pending is the main thing we're dealing with. P0102, that's what's happening here. So we have this snowflake on the side we can look at, and that'll give us the freeze frame, basically the black box of this vehicle. When this issue was detected, it'll give us a screenshot of hopefully integral PIDs to help determine the setting conditions, and we can emulate those in efforts to resolve, or not resolve, but we can emulate those in efforts to replicate the problem, assuming that it's an intermittent issue. This is not. This is just a solid problem. So this, I can clear this code. It comes right back immediately. Let's go to, let's see what mass airflow is, because this mass airflow is pretty much dead in the water. If it's in here, you know, sometimes strangely they won't give, there we go, right there. This is pounds per second. You'll want to get that converted over to grams per second. We'll do that in the live data. So here, the vehicle, we saw 0 RPM at the top here. The car doesn't even have to run for it to detect the problem because it's a circuit integrity issue. So let's go back into the live data portion. As a matter of fact, let me show you that you can't clear this code. Key is on, clear code. Okay, yep, still pending. Let's go to live data. All right, so we have number of codes. We have one. Let me start it right quick because I want to show you something that's pretty important with this particular car. So typically when you get mass airflow codes, you're going to look at fuel trims. Let me show you that. Let's go down to fuel trims. There we go, long term and short term. I think this probably would throw a lot of people off here. So short term is -20. Long term is at 0, which is interesting because before, let me give it some, yeah, okay, I gave it throttle and it is making some sort of accommodation. Before it wasn't showing it, but being that it's taken away, which is strange because it's dead in the water, is low. It's a low value. It should be adding if anything, but the vehicle is going to be in the default strategy because there's a circuit fault. So I'm going to ignore this, but just make mental note what's going on. The long term has not made any sort of accommodation when it's accompanied with a circuit fault. So you're going to have to take some information with a grain of salt here. But that is vital information. Let's go to mass airflow. We at pounds per second. I need to convert this over to grams per second. And this is as far as it's going, 0.01 grams per second. So this is not, it's not moving. It's just pretty much dead in the water. Even after clearing the code, going back into live data, the mass airflow sensor is just not working. So if you go into the bidirectional portion, this is the code that comes up, P010014. So it's P010014, and it's confirmed, test failed, and pending. Mass or volume airflow sensor A, circuit short to ground or open. That's the code you get if you go into the bidirectional portion where it detects, auto detects the VIN. So back here in live data, we still see that the mass airflow is not doing anything. I mean, we can look at, you know, aperture ratio sensors, but that, based off of what the car unsatisfied condition is, we don't need to look at anything else but satisfy what the conditions are. Being that the mass airflow has an integral part for operating, it's pretty much in the default strategy right now, and it's not making any sort of accommodations. So all the other components that we're going to have to look at is irrelevant. Let's just satisfy what is unsatisfied, which is that mass airflow circuit. So let's go check that out. So the key is on, engine's off right now, obviously. So one thing I would want to do, being that the mass airflow has two different sensors in there, such as the air temp and the mass airflow, I just want to disconnect it. Let's go into the, since we're already in live data here, where's our air temp sensor? So now we generated another code. And engine coolant temp, we should have, yep, There's our air intake temp sensor here. That is also integrated inside of here. So we know, based off of a process of deduction, this is a 4-pin connector. They're going to share power and grounds. We most likely have a recipe for a working unit. We just have potentially a circuit integrity code for a signal size. So we have power. How is our signal looking? Let's plug this in. It goes back to 82 degrees when plugged back in. So let's find the signal side, and if we can tap into the 5-volt reference, or however this is controlled, and manipulate that to see if it reflects in the computer live data, then that will indicate pretty much we have the pathway to good signaling. Let's find the signal side for the mass airflow sensor and go from there. All right, let's check the circuit. I got my ground on negative, and I'm just pretty much going to pierce each of these, and I'm going to do it with the vehicle running. So with the car running, since this mass airflow is very ineffective right now, we're just pretty much going to test the pins. So one is going to be on the far left. Let's see if I can zoom in a little bit. One is going to be on the far left, and 4 is going to be on the far right. We got 5 volts here on 1, 2, 0, 5 volts on 3, 5 volts on 4. So number 3 here is going to be our actual power source. And let me show you that. I'm going to take a test light, and with this particular vehicle, it's not a good idea to pierce random things because you can create problems. This is a usable voltage. All these other ones here are pretty much just signal wires. This is going to be a ground. This one here, number 2. Number 1 is going to be our signal for the mass airflow. All right, so let me just go back over. Mass airflow signal is going to be here. This should be a ground. This should be power. And this is also going to be signal here for our, lightly for our temperature. So one thing we didn't check was for ground. I have my alligator clamp here on 12 volts. So we already know number 1 is going to be our signal for our mass airflow. Number 2 is going to be our ground, and the test light is illuminating. Number 3 is going to be our 5 volts, our usable 5 volts. And number 4 is going to be our signal for our ambient air temp sensor. So with that said, being that the voltage is high, this is going to be a pull down system. So it seemed like the lower the voltage go, the higher the value, and the higher the voltage, the lower the value. So being that we're going to use this test light to pull down the voltage. That's hooked up on negative right now. Test my test light. It's illuminating on the battery positive. Being that the voltage is high, we're at negative 40. We're going to bring it up by taking a test light and grounding out that signal wire. So let's take this. Let's see if the computer, so we'll focus on that. So we're going to focus on this. So we're going to go to number 4 and ground it out, and it maxes out at 284 degrees. Let's go over to number 1, which is the signal side. Max this out. Is it going to do anything? Uh-oh, I hit ground on that one. There we go. So if I hit the ground on number 1, the value does change and it spikes up. I don't know why, but I think it needed to complete a circuit. I did touch the 5 volt reference There you go. So if you back off and touch it again, it'll change. So that did max out. So there was some change with the mass airflow doing that same test for the air intake. I don't know if it has to be. So if I hit it again, it does change state. That's the main thing. I just want to see it change. So we have the recipe for a working unit. We got ground. We test that. We have 5 volts positive, and we can manipulate the signal, so which indicate that the continuity from here to the computer is fine. Now again, it's not a good idea to pierce around the 12 volt. I did hit the 5 volt reference with a 12 volt, and it did cause some sort of chaos. And let me see if I can point that out. Let me see if any codes came up. And if you do make this mistake, you're going to have to go in and do a complete scan of all the modules and clear all the codes. So those are the codes that came about if you mess something up, if you like accidentally pierced the wrong thing with too much voltage, such as that 5 volt reference, control module processor, TCM processor, and it just wouldn't start up and run. So what you're going to have to do is go into the bidirectional portion, do an auto scan, clear everything, and let it sit for a little bit. Let me see if it starts up now. Okay. Yeah, so it starts up fine. I didn't mess up anything from what I was piercing, but if you happen to hit the 12 volt, take the 12 volt on the test light and hit that 5 volt reference, you're gonna make this car very unhappy. So anyway, that's the simple diagnosis. The circuit fault, everything has the capabilities of working. The only thing I need to do is throw a mass airflow sensor in it. That's it. I don't need to think of anything further. Powers, ground, signal. That's it. So I got a mass airflow sensor ordered from O'Reilly's. That should be here on Tuesday, because it's Sunday night right now. I said, let me just go ahead and do half of this video, and then it'll come in and then we just pop it in there and look at the mass airflow sensor work. So that's going to be it, and I will see you in a few days. And I don't know where to start. This day has been nothing but pure shit. I'm just going to be honest. So hopefully something can go right. Me fighting with the dealership and from Honda because I need to replace another warranty on that 2018 Accord where the injector failed again. This is the second time. They want to charge me for a diagnostic, and I'm like, I just need a part, because not only did number 1 fail earlier, but number 2 failed. But I don't want to get into that. I just been making a plethora of bad decisions today. So anyway, the only good thing that happened, Toyota saved, balanced out the day. That was the trend to make things a little bit better. O'Reilly's, I'm not gonna say they screwed up, but that was a screw up. I thought that we can get the mass airflow sensor for about $190 to something through O'Reilly's, but they ordered the wrong one. The new one, the one that's correct for this vehicle, was going to be $398, and it was going to come from Atlanta to get down here tomorrow. Now go. So I called the dealer. They actually had a new mass airflow sensor for $240 factory. So there's the part number. I think that should have been the part number there. It's exactly the same, because there's a variation to where there's a 3.5 and then a hybrid version. This is the non-hybrid, but this is what it looks like, obviously, and it's OEM. So big thing is, when I plug this in, is the value going to change and go back to normal? Did I diagnose this properly, or did I screw up like the rest of the decisions I made all day? So here we are. Let's get this camera set up and zoomed in on the PID data, because I haven't plugged this in or anything, and we're going to see this together. Let me see if I got the camera properly. Yeah. Wish me luck. Well, what do you know? Somebody literally called my phone. Yep, it's working. I can blow on it and it don't sound right. I can blow on it and it moves. See how the values change. That's how sensitive the mass airflow sensor is. So we did diagnose this properly. I diagnosed this properly. I'm gonna take credit for my damn self. Screw y'all. Because some of you people that watch my oil change video can't even go into these complex videos and give me some insight. Let it be oil change. Let's take this out, get the new one in there, and get this vehicle fixed. I know what I captured. I had a lady call because she got to come by and bring her car here. So out with the old, in with the new. I can tell you, sometimes it's best to stop making decisions. And this is just a note for myself in the future. Just go with what you know. Go with what's good. Go with what you're great at. That's what I'm gonna say. Stick to what you're great at. I see why people say, don't quit your day job if you're gonna try something a little different. But yeah, stick to what you're good at. And maybe vague to you, but I understood it. All right, let's clear these codes out. Start it up and watch this work. So our circuit fault code should now be gone instantly. We shouldn't have to worry about that coming back because that was an immediate comeback code. As soon as this thing will open, there we go. Come on here. I think that's the benefit of my new computer, is super fast. There we go, car's off. And we should not have a code. I'm gonna exit out and then I'm just gonna jump right back in it. I should have just hit the read code button. I keep forgetting that feature is down there at the scan tool on this one. No code, so this circuit issue is fixed. And like I was saying, those are the easiest codes to resolve, is the circuit integrity code. Just make sure you got powers ground and you can manipulate and influence the signal. Boom, there you go. Let's go in the car and see if it works like it's supposed to when we start it up. The impact sensor that has gone off, so that took care of quite a few things. Come on here and focus. So there's no codes. Let's go back and check, and then we'll just go into the live data and see what our mass airflow is doing. The general rule of thumb, you want the displacement of the engines 2.5 at 500 RPM, so I'd imagine this should be flowing around 3 grams a second, probably between 2.7 2.8. I'm going with 2.8, but then again it's idle. Oh, I'm wrong, but it's idling a little high too. Let me give you the RPM just in case someone else want to compare a good mass airflow sensor to. I'm putting engine speed because I think that's where it's listed under. Engine speed. There we go. No, wait, where's the engine speed? Right there. Let's isolate those PIDs. So there's our engine speed to our mass airflow grams per second. So you can look at that and compare yours. Let me go to 2000. The vehicle's still in open loop. Let's check our fuel trims and see if they are now moving. There we go. There's our long term. Here's our short term. Let's isolate those PIDs, and I'm going to take this coolant temp sensor here. So there's our PID data if you want to evaluate your mass airflow sensor. So our long term is taking away 7%, which is perfectly fine. The short term is taking away 7%, which is fine. The long term will eventually accommodate once it hit closed loop if it need be. So we're in good shape, and I know I'm gonna be right. So once it goes down to about 800 or so, this should be flowing around 2.7 grams, 2.8. I'm gonna let it do its thing, and then I'll come back when it reaches normal temperature. Here's our value at 132 degrees, around 700 RPM. So we're dropping down to 2.4 grams per second, and we're taking away 5% on the short term. So the engine overall is running phenomenally. There's not going to be any issues with this. So we've been through the assessment, the diagnosis, very simple, nothing out of the ordinary. And like I said, circuit faults are the easiest to diagnose for me. And there's nothing to be intimidated about. Just don't chase your ass. The car told us what it was unsatisfied with and just pretty much went along with it. Check for powers, grounds, see if you can manipulate the signal and see if it reflects in the computer system. And again, we have to have bidirectional tools to work on these cars now. We just can't use regular scan tools, for the exception being that we had, I take that back, because you can use a generic OBD scanner, but it has to have live data. So it shouldn't have any sort of delayed information. Some scan tools, well, some manufacturers are like that, where you try to manipulate the signal, key on, engine off, it goes into a default setting and ignores the values. So we didn't have that with this particular case. So it worked out very good. Good job, Toyota. Toyota just saved the day today. It leveled out my day, I'll be honest. But anyway, if anything happened, I'll definitely update. But hit that link, subscribe to the channel, stay informed, had a rich on some more work. See you on the next one.